An internet protocol is a set of rules that tells computers and devices how to communicate over a network. Every time you browse a website, send an email, stream a video, or download a file, multiple internet protocols work together behind the scenes to make it happen. Some protocols are responsible for delivering data. Others make sure the data arrives correctly, while others keep your information secure. Without these protocols, the internet simply wouldn't function. So now let's break down every major internet protocol and see what each one does. IP, Internet Protocol. The Internet Protocol, or IP, is the foundation of the internet. Its main job is to identify devices and deliver data from one location to another using unique IP addresses. Every device connected to the internet, whether it's a phone, laptop, or smart TV, receives an IP address. When you visit a website, your computer sends data packets containing the destination IP address, and routers across the internet work together to deliver those packets to the correct destination. However, IP itself doesn't guarantee that the data will arrive correctly or in order. It simply focuses on routing the packets. IPv4. IPv4 is the fourth version of the Internet Protocol and remains the most widely used addressing system today. It uses 32-bit addresses, allowing for about 4.3 billion unique IP addresses. An IPv4 address looks something like 192.168.1.1. While this seemed like more than enough when the internet was first developed, the rapid growth of internet-connected devices eventually exhausted the available addresses. IPv6. IPv6 was created to solve the address shortage of IPv4. Instead of using 32-bit addresses, it uses 128-bit addresses, providing an almost unlimited number of unique addresses. An IPv6 address looks much longer, such as 2001/DB8/8A2E/0370. Besides offering vastly more addresses, IPv6 also improves routing efficiency, security, and network performance. TCP is responsible for making sure data reaches its destination accurately and in the correct order. Before sending information, TCP establishes a connection between two devices. It divides large files into smaller packets, numbers each packet, checks for errors, and retransmits any packets that are lost. This makes TCP highly reliable. Activities like web browsing, file downloads, online banking, and email rely heavily on TCP because accuracy is more important than speed. UDP, User Datagram Protocol. UDP takes a different approach from TCP. Instead of checking every packet, UDP simply sends the data as quickly as possible without waiting for confirmation. This makes it much faster but less reliable. If some packets are lost, UDP usually doesn't resend them. That's perfectly acceptable for applications like online gaming, video streaming, voice calls, and live broadcasts, where speed is more important than perfect accuracy. HTTP, Hypertext Transfer Protocol. HTTP is the protocol used to load websites. Whenever you enter a web address into your browser, HTTP tells your browser how to request web pages from a web server and how the server should respond. Every web page, image, style sheet, and script you view on the internet is typically transferred using HTTP. HTTPS, Hypertext Transfer Protocol Secure. HTTPS is the secure version of HTTP. It works exactly like HTTP, but encrypts all communication between your browser and the website using SSL or TLS encryption. This protects sensitive information like passwords, credit card numbers, and personal data from hackers. Today, nearly every major website uses HTTPS, and modern browsers even warn users before visiting websites that don't use it. DNS, Domain Name System. The domain name system acts like the internet's phone book. Humans remember website names like google.com, but computers communicate using IP addresses. DNS translates those easy-to-remember domain names into numerical IP addresses so your browser knows where to connect. Without DNS, you'd have to memorize long strings of numbers for every website you wanted to visit. DHCP, Dynamic Host Configuration Protocol. DHCP automatically assigns IP addresses to devices joining a network. Instead of manually configuring every phone, computer, printer, or smart device, your router automatically gives each one an available IP address along with other important network settings. This makes connecting to networks much simpler. FTP, File Transfer Protocol. FTP is one of the oldest protocols used for transferring files between computers. It's commonly used by website developers to upload website files to web servers. FTP can transfer large files efficiently, but it doesn't encrypt the data, making it less secure than newer alternatives. SFTP, SSH File Transfer Protocol. SFTP is the secure version of file transfer. Unlike FTP, all files and login credentials are encrypted during transmission. This makes SFTP the preferred choice for businesses, developers, and organizations that regularly exchange sensitive files. SMTP, Simple Mail Transfer Protocol. SMTP is responsible for sending emails. Whenever you press the Send button in your email application, SMTP delivers your message from your email provider to the recipient's mail server. Without SMTP, email communication wouldn't be possible. POP3, Post Office Protocol version 3. POP3 is used to receive emails. It downloads messages from the mail server onto your device and usually removes them from the server afterward. This allows users to read emails offline, although it can make syncing multiple devices more difficult. IMAP, Internet Message Access Protocol. IMAP also retrieves emails, but instead of downloading and deleting them, it keeps messages stored on the mail server. This allows your inbox to stay synchronized across multiple devices. If you read an email on your phone, it will also appear as read on your laptop. SSH allows administrators to securely connect to remote computers over the internet. Instead of physically sitting in front of a server, an administrator can log in remotely and perform maintenance, install software, or troubleshoot problems through an encrypted connection. Telnet. Telnet performs a similar function to SSH by allowing remote access to computers. However, Telnet sends all data, including usernames and passwords, in plain text without encryption. Because of its poor security, Telnet has largely been replaced by SSH. SSL, Secure Sockets Layer. SSL was originally developed to encrypt internet communications. Although SSL itself is now considered outdated, the term SSL certificate is still commonly used today. SSL laid the foundation for secure online communication. TLS, Transport Layer Security. TLS is the modern replacement for SSL. It provides stronger encryption and better security for HTTPS websites, email systems, messaging applications, and many other internet services. Most secure internet communication today uses TLS. ARP, Address Resolution Protocol. ARP works inside local networks by translating IP addresses into physical MAC addresses. Since devices actually communicate using hardware addresses, ARP helps computers locate one another on the same local network. ICMP, Internet Control Message Protocol. ICMP is mainly used for network diagnostics and error reporting. One of its most common uses is the ping command. When you ping a website, ICMP checks whether the destination is reachable and measures how long the response takes. NTP, Network Time Protocol. NTP keeps computer clocks synchronized across networks. Accurate time is essential for banking systems, security certificates, logging events, and many internet services. Without synchronized clocks, many secure systems would fail. SNMP, Simple Network Management Protocol. SNMP allows network administrators to monitor routers, switches, printers, servers, and other network devices. It helps track performance, detect failures, and manage large enterprise networks. RDP, Remote Desktop Protocol. RDP allows users to remotely control another computer as if they were sitting directly in front of it. Businesses often use RDP for remote technical support and managing office computers from home. SIP, Session Initiation Protocol. SIP is used to establish, manage, and end voice and video calls over the Internet. Services that provide Internet-based phone systems often rely on SIP to connect calls between users.